Welcome to today's webinar, Running Microservices and Docker on AWS Elastic Beanstalk. Presenter today is Brandon Chavis. Brandon is a solutions architect on the partner team where he works with AWS technology partners to architect scalable and cost-effective solutions in the cloud. His primary focus is Docker, EC2 container services, and building the container ecosystem on AWS. Today with us, we also have Thomas Robinson, Mike Caliber, and Adaraj Singh. They are our webinar moderators, and they will engage with you and answer your questions throughout the presentation while Brandon presents. Brandon, welcome. The floor is now yours.
Great. Thanks so much. Hey, everyone. I'm Brandon. I don't really need to introduce myself too much. I've already had a wonderful introduction here. I will say, don't pay too much attention to the subtitle of this slide, as it's a little inconsistent with the topic of the webinar that you're expecting. But we are talking about Docker and microservices on Elastic Beanstalk today. I do encourage you to leverage the moderators that we have here. So we have 3 people in the room to answer your questions kind of on the fly. So when I inevitably explain something in a way that's difficult to understand, feel free to reach out and we'll answer your questions. And then at the end, we'll also have a quick Q&A session to make sure that everyone understands everything that we discussed today. So without further ado, we're talking about AWS Elastic Beanstalk today, which is a service for deploying and scaling web applications. So the agenda for today is pretty straightforward, and I suspect that, as usual, we have a really wide range of experience on the webinar today. So if you're really new to AWS and Elastic Beanstalk, don't worry, because we'll cover a little bit of the basics of Elastic Beanstalk, so what it is, why you'd want to use it, and we'll progress to how you can actually get started using it. So we'll focus on that usability aspect in the context of deploying Docker applications to the multi-container Docker environment type. We'll compare and contrast that environment type to some others that we have in Elastic Beanstalk. And then finally, we'll demo how this works. So we'll go from some code to building a Docker container and deploying it onto Elastic Beanstalk. And we'll talk about some of the associated services that are required to make that work. And then finally, we'll chat a bit about some of the new features on Elastic Beanstalk. All right, so let's go ahead and get started. So I think like everything in AWS, we built Elastic Beanstalk really to solve a customer problem. And I think that we all know it can be pretty difficult to be a developer right now because there's just so much to know. And you might be expected to be awesome at everything. So you might be an excellent Java developer, but you might not know anything about Elastic Load Balancers. Or you might be a really strong ops engineer, and you just need to get some code deployed, but you really can't spend all of your day and all of your time configuring, the full architecture stack and fiddling with components of the OS. You basically have some code and you want to get it running in the cloud. So, we really understand this challenge here at AWS. Me in particular, I find it difficult just to stay up to date with AWS new releases and features because they're so rapid. So really, Elastic Beanstalk here is intended to help address some of these challenges that you might have as a developer. So Elastic Beanstalk is built to offload much of this heavy lifting from you and get your code deployed into a best practice AWS stack, or maybe a common sense AWS stack with minimal configuration on your part. So we like to say that Elastic Beanstalk is impossible to outgrow, and that's because it's built with growth in mind. It's really built around the concept of scaling with your needs. So as your application grows, the underlying environment and infrastructure can grow with you. And again, that core focus is really to enable you to focus on your application by providing you a range of pre-configured environments. So Elastic Beanstalk will spin up instances that are pre-configured with software and config files, application or web server frameworks, basically everything you might need to run your code. So in my opinion, this is wonderful not only because it minimizes the configuration you need to do yourself, but it also enforces kind of a common baseline config on all of the instances in your environment. So that minimizes the risk of dependency drift for your software. Beanstalk can be a little bit opinionated about the way things should be deployed, and you'll see that we have some common stacks that come with a declared set of software available on them, and we'll take a look at some of that in just a little bit. But looking at this graphic here, what's highlighted in blue here on the left, your code is the pretty little green box on top, and then everything else highlighted in black is provided by Elastic Beanstalk. So there is an HTTP server, there's an application server underneath, There's a language interpreter, so there's Java or Python or Go installed on the instances. And of course, we have the operating system underneath, which is generally Amazon Linux. And then of course, the host, which is provided via EC2 underneath. So all of this is automatically available for you in Beanstalk, and you bring your code, and that's all that you have to worry about. So not only is the EC2 instance configured for you at the operating system level, but there's also an entire pre-configured architecture stack that's spun up for you. So you can, of course, choose to run this in slightly different configurations. So you can have a single instance deployment if you're looking to save costs just in your development environments, for example. But you can also just as easily spin up an auto-scaled and load-balanced environment right off the bat. So you can choose between maybe a web tier environment, which is your more typical 3-tier web app, or a worker tier, which is a little bit different in that it's an environment that focuses on handling asynchronous work, specifically work that's driven from an SQS queue. So the full stack includes a custom Route 53 DNS name for each application, an elastic load balancer, EC2 instances, one or more EC2 instances in an auto-scaling group, and then optionally a backend persistence layer like an RDS database. So you also get a lot of the glue in between all those pieces. So you get things like an S3 bucket, which can be used to store your logs or your source code. You get security groups, you get CloudWatch alarms, and the underlying resources that Elastic Beanstalk spins up, they are your AWS resources, right? So they're the same resources that you're used to in the sense that they run in your account. You can maintain full control over them, but Elastic Beanstalk really provides this nice platform layer on top of all these services, aggregating them together into a single control layer through Elastic Beanstalk. So some common use cases, it's pretty straightforward. As I mentioned, the three-tier stack works very well for things like websites and API backends. We see a lot of mobile applications deployed into Elastic Beanstalk. And again, with the worker tier environment type, we also support asynchronous workers. So again, that's less focused on handling web requests or web applications, but more focused on processing asynchronous work from an SQS queue. And that might be something like an image processor where an image is uploaded to your website and the worker tier will compress it, create a thumbnail, and upload it to S3, for example. So that's a common example of an asynchronous worker. Beanstalk is really suitable for a wide range of use cases. So we see maybe a little mom and pop shop with just a single developer who just want to get their code up to the cloud. They're using Elastic Beanstalk. But also we see global Fortune 500 companies running many applications on Elastic Beanstalk. So Zillow, for example, they run both front-end APIs and their asynchronous image conversion applications in different Elastic Beanstalk environments. Zillow likes Elastic Beanstalk because their workloads are unpredictable, and they like the ability of Beanstalk to kind of scale up automatically in response to these load fluctuations. So to summarize, why would we want to use Beanstalk? Beanstalk is a really convenient management layer for the AWS services that you know and love today. And Beanstalk itself is totally free. So you pay for the underlying resources, but to use those resources through Beanstalk does not cost you anything extra. We also think it's probably the fastest and simplest way to deploy your application to AWS. So you simply upload your application, and Elastic Beanstalk handles automatically provisioning the environment, all the deployment details, and generally within minutes your application will be ready to use without any infrastructure or resource configuration work on your part. So Beanstalk provisions and operates the infrastructure and manages the application stack for you. So you don't really have to have the time to develop the architecture stack or the expertise to know all the individual components underneath. So you can really focus on just writing your code instead of managing and configuring servers, databases, load balancers, firewalls, networks. And then finally, Elastic Beanstalk handles automatically a lot of the scaling requirements of your application. So it will scale up and down based on the application's specific need. And it provides you some easily configurable auto-scaling settings that you can take a look at if you feel like the default behavior is not working for you. So for example, there you could use CPU utilization to trigger auto-scaling actions. So once your aggregate CPU load across your entire environment reaches a certain percentage, Beanstalk will automatically trigger a scale up and launch more instances into your environment. And the final thing that's pretty cool, I think, is that Beanstalk lets you open the hood, so to speak, which means that you can retain full control over the underlying resources that are powering your application. So if you decided that you wanted to take control over the instances that Beanstalk launched for you, you can do so seamlessly, and that's totally okay to do. So let's talk about actually getting started with Beanstalk here. So you need to make a few decisions when you deploy to Elastic Beanstalk. Or rather, you have to answer a few questions, I guess. So we'll go through this process later on in the demo. We'll walk through the console here. But number one is you have to choose an AWS region. So this is a decision you have to make based on where are your customers. You want to place probably your environment in a region that's closest to the majority of your customers. So if you're on the East Coast, you can choose US East 1. Or you can pick a data center that one of our carbon neutral data centers if you have a green kick, for example. So any of these options are suitable, but take a look at that and pick the correct region for you. Secondly, pick your stack or container type. So this probably really isn't a decision you have to make, but rather just picking the right platform that corresponds to what you've written your app in. So some supported platforms include Java. So we have both Tomcat and Jetty. We have Go, we have PHP, we have .NET, there's Node.js, there's Ruby, and there's Ruby with Passenger or Ruby with Puma, there's Python. So there's a number of different options. There's Docker, which we'll talk about today, and we'll talk about kind of how those differ from each other, even if just slightly. So then third, you should answer the question, is this a development environment or a production environment? So if this is a development environment, I'd recommend you choose the single instance type. To help you be frugal, so you can save some money. You can use a T2 micro and use that within the free tier if your account is new enough. Otherwise, go hog wild and get that auto-scaled and ELB environment. So you can have multiple instances of your application running in your environment. And then last, you should answer the question, do you need a database with your stack? And this is to answer this question, you should probably understand one note here about RDS databases with Beanstalk, is that if the database is launched through Beanstalk for your environment, that database is tied to the lifecycle of your environment. So if you have data that will exceed the lifecycle of your particular environment, you might want to launch the database separately and connect that after the fact. And that's actually how we're going to do the demo today, so we'll show you how that will work. So that's what you need to keep in mind. So answer these questions and you'll be on your way to deploying your application. So in Elastic Beanstalk, applications serve as a container for the environments underneath that run your web app. So applications are the top-level construct in Beanstalk. And underneath an application, you can have a number of environments. And these environments can be different versions of your application. They can be, some of them could be the single instance type. Some of them can be the load balancing auto-scaling type. They can be written in different languages, for example. So amongst different versions here, you see we've moved from PHP early on to a Node.js implementation of our environment in the most recent versions. So you can have all of these running and fully independent, running in parallel. So this gives you the ability to maintain multiple versions and roll back to a previous one fairly easily if you needed to. So when it comes to actually deploying the application, there's a number of ways to do this, and we like to give you a lot of choice. And so the number one way, the most obvious way, is the AWS Management Console. And I say that is obvious because it's usually the first place people start with AWS, and we'll look at the console today and how to deploy a Beanstalk application through it. There's also plugins for a number of IDEs, namely Eclipse and Visual Studio. So you can actually, from within your IDE, deploy directly to Elastic Beanstalk after some configuration. You can also directly use our SDKs, which are available in a number of different languages, or our command line interface. And then finally, there's a dedicated Elastic Beanstalk command line interface called the EB CLI, and that gives you a number of commands to manage Elastic Beanstalk environments directly from that CLI. We'll talk about EB a little bit more in the future here. So if you wanted to use EB, it's pretty easy to get started. So the first thing that you would do is you would install it via pip. There's also a binary you can use to install it. But once that's installed and you change directories into one of your Git repositories, EB has Git integration. So the first thing that you need to do is type EB init, which basically hooks the EB CLI into your Git history. And EB can do things like make sure that you're only deploying the latest version of your application. So if you have staged changes, for example, that have not yet been committed, then Beanstalk will not push those, will not deploy those into your environment, and instead will only deploy the changes that have been committed to your repositories. It's a really nice feature. But anyway, when you do EB init, there's a little text interface that comes up, and it will give you some options to configure the environment, and you can actually deploy a brand new environment through the CLI this way. And then finally, EB create is what will actually take that configuration you've applied with EB init and launch those resources in AWS. So similarly, there's a easy workflow here to update your application. So that's something that, if you're using Beanstalk, chances are you're pushing changes to your application pretty frequently throughout the day. And so here's the Git integration I was mentioning earlier. So once you add your changed files to your Git repository and you commit them, you can do an EB deploy, and those new changes will be pushed to your environment. EB also gives you, if you're using a windowed environment, the option to do EB open, which will pull up your environment in your browser just from running that text command. So it's pretty neat. There's some fun features of EB that we'll show you later, especially as it pertains to running Docker containers. So now what we're here to talk about is running Docker with AWS Elastic Beanstalk. And first, let's cover what some of those benefits might be. So again, a lot of the stock Beanstalk benefits, so the automation of capacity provisioning, setting up the load balancing, auto-scaling, kind of deploying all those things for you onto which you can deploy your Docker containers. And again, it's that management overlay that really allows you to harness all of the underlying AWS services that you would need to run your application. And so you can do things like configure what VPC it goes into, if it should use RDS, how IAM should be configured, so fine-grained permissions handling. All of these things Beanstalk provides you, and this applies to the Docker environments as well. So there's some questions you might want to ask yourself when you're deploying a Docker container onto Elastic Beanstalk, and some of these things you'll have to understand how to do before we get a fully running environment into Elastic Beanstalk. So one of the questions might be, after I've built a container, we've done a Docker build, where do I then put those container images so that Elastic Beanstalk can access them and pull them into my environment? How do I specify the configuration of these containers for Beanstalk? So how do I ensure that they're configured the way that I want them when they're running in my Beanstalk environment? Is there a way for me to test this config before I push it to Beanstalk? So after I write that configuration file, can I test it locally? How do I actually deploy the containers to Beanstalk? So we'll look at that. We'll talk about how to get those up to Beanstalk. And then how do I update my application once it's actually running in Beanstalk? How can we update that environment and change the containers that are running? So number one, you need a place to store your container images. And we have Amazon ECR, which is EC2 Container Registry, and we think that this is a great option for a number of reasons. But Beanstalk can interact with any Docker repository, so you can use public Docker Hub, you can use ECR, and you can use your private repos. So if you're running Docker Trusted Registry in your VPC, for example, Beanstalk can certainly use that as well. The reason we like ECR so much, and I think the reason a lot of customers like it as well, is because of that IAM fine-grained permissions that ECR allows. And we'll talk about kind of how to configure this in just a little bit in the demo. But for one of the awesome benefits, you can assign an IAM role to an EC2 instance, to the instances that are running in Beanstalk. And Beanstalk can use that policy to access your images in ECR, and you don't have to provide any additional configuration. You don't have to store a username or a password or anything like that to access the repository. So that's fantastic. Automatic authentication with ECR is really, really nice. We'll show you how to make that work. So when you create an ECR repository, we'll walk through this process, creating a brand new one. But when you create a repository, we prompt you with some options on how to properly build and tag images and then push them up to this new repository. So once that's done, once you actually have some containers pushed up into that ECR repository, you can configure the permissions. So you can set images as public, for example, or you can restrict specific permissions to certain profiles or certain users within ECR. So that ability to control it via IAM, again, is one of my personal favorite features here. So I might be missing some components on this slide, but that is okay. So the most important part of deploying Docker containers to Beanstalk is the configuration file, which is called the Dockerrun.aws.json file. And so this file is what actually references the containers that will be deployed to Beanstalk and how they will be configured. So some important components here, there are two versions of this Dockerrun file. If you want to use the multi-container Docker environments, you must use version 2, so we'll look at that. Version 1 was only single container Docker environments. This also gives you the option to do things like configure volumes, so a mount point that the container can use. And these volumes are just maybe EBS volumes that live on your instance, and you provide a directory path to access that volume, and it gets mapped to a directory inside the container as well. So containers can write data that's passed through to EBS volumes underneath. And then the container definition, so let's look at those. So this is a quick snippet of a dockerrun.aws.json file. There's sections for defining volumes, for defining the container definitions, defining the version of the Dockerrun file that we're using. And this is also where you specify things like how much CPU and how much memory should be allocated to each container. Should they have any port mapping? So should my container have port 80 mapped on the host, for example? And then finally, should we provide any authentication to the container? So this would be where if Beanstalk needs to access a private repository, you can pass that configuration via this file. So we'll look at this in an editor later where it's a little bit easier to read. There's also an awesome feature here for testing your Beanstalk applications locally that I'm a big fan of, and that is EB local run. So from within your project directory, using that dockerrun.aws.json file, EB local run will find that configuration file, and it will parse it and then spin up the containers you've defined within locally on your local Docker daemon. So that way you can test that your containers actually start up, that your links are working properly, that everything's defined correctly, and it's parsing properly before you actually submit it to Beanstalk and find out after waiting for a little bit that there was a little misconfiguration that maybe slipped your mind while you were building the config. So again, you need to choose the right Beanstalk container platform. There's two options, single container and multi-container. Ironically, you can actually define a single container in the multi-container version. So my general recommendation is to go with the multi-container configuration in case you decide that you want to have another container defined within that particular dockerrun.aws.json file. So the underlying architecture is an interesting component. And much like the rest of Beanstalk environments, we're again providing a convenient overlay for another AWS service underneath. So in this case, the multi-container architecture is overlaying EC2 container service. And so therefore each each environment gets its own ECS cluster. So we can look at the cluster that gets spun up by Beanstalk when we walk through the demo. But in general, each cluster will get a single ECS task definition. So that dockerrun.aws.json file gets parsed and turned into a task definition and then spun up on the cluster. So that cluster can contain multiple instances. And those instances each instance will have the same task placed on it. So if you have a couple of containers defined, maybe 3 containers defined in your dockerrun.aws.json file, like in this example here, all 3 containers will be placed in the same task on the same instance, and then you'd have multiple iterations of that same set of containers on each instance. So we use what's called a flood scheduling mechanism, which is kind of a fancy way of saying that we find an open set of resources in the clusters. We find a container or an instance that can run your containers, and then we schedule it. So we call ECS run task underneath, and we place those containers onto the instance. This is a really nice way to get out-of-the-box auto-scaling for ECS tasks in the sense that because there's one task and one set of containers per instance, every time we launch a new instance, you add another set of containers. So it's a very straightforward method of auto-scaling and works quite well. So there's a couple of example repositories you can use to spin up a demo multi-container environment with relatively low effort. So this is one example, and these slides will be available later, so you can click on this repository link and do the demo. We'll be demoing a slightly different application today, and you can also look at that. So there'll be a number of options for you to do an initial deployment and understand kind of what this workflow looks like. In this case, in this example, there's an Nginx reverse proxy and a PHP application, and they're linked together. So on every instance, you have Nginx fronting a PHP app. And as we scale that up, you simply get more Nginx and more PHP containers running together on an instance. So let's talk about application deployment real quickly. So this is really important for many people that use Elastic Beanstalk. Our customers want a lot of flexibility when it comes to deploying applications to Elastic Beanstalk, so we give you a number of different options. Right now, we'll talk about rolling deployments, and there's a number of different rolling deployments that we provide. But also, there's a couple of different ways of doing deployments, and we're going to step through all of them here actually real quickly because we're getting a little bit close on time. So you can do all at once, which means that if you have version 1 running on your application, we'll just kill all version 1 and run version 2 on all the instances in your cluster. This has some potential downtime for your application, so it might be a very quick way to get your new application out, but do consider that it might impact users that are currently using your service. There's also the option to deploy your new version of your application in batches, so we call this a rolling update. So you can select a percentage of your existing fleet to which you should deploy the new version of the application. So you might select that I only want to deploy my new version of the application to 50% of my fleet. So you might lose 50% of your service capacity during this rolling deployment, but if that's all that you need to maintain, then that should be fine. If you cannot handle any sort of application downtime or service reduction, then we have a fairly new feature called rolling with additional batch. And this means that we'll do just what rolling deployments were, so we'll deploy a small percentage, or we'll deploy your new application to a small percentage of your fleet, but first we'll launch an extra batch. So this way, if you say, I want to deploy my application to half of my fleet, first launch another set of instances to deploy that half of my application to. So we maintain 100% service capacity throughout the whole time. And we'll look at this with some graphics in just a minute. So immutable is another new option relatively, and this is just, I think, a really awesome option to maintain service capacity. So you can deploy your application to a fresh group of instances, which means that we'll spin up all new instances before we deploy your new application, and then once those new instances are up and running, we'll swap them into service and then terminate the old instances that are running the old version of your application. So some ways to visualize this, because it's kind of tough to grasp it all when I'm just talking about it. All at once, fairly straightforward. There we go. We go from V1 to V2, and there might be a little bit of service interruption in between, but it's a very straightforward method of deploying your application. And this might be used again, for example, if you just really need to roll out that new version. This is also useful for rollbacks if you've noticed an issue with your new application, or if your new version of your application is just incompatible with your previous version, for example. Rolling with additional batch. I'm a big fan of this option. So notice we have 4 instances running with version 1 of our application. So we're going to deploy 2 new instances and deploy V2 to it. And then we're going to check them into the load balancer. So we've increased our total service capacity here before we actually drop some of the previous service capacity out. So we started with 4. During our deployment, we maintained 4 instances, so we're still at 100% service capacity. Then we start gradually rolling out V2. We check the 2 new ones into the load balancer. And finally, we drop V1 out entirely, and we're left with just version 2 of our application running. So throughout this process, we maintained 100% service capacity. The last option is blue-green deployments, and these are really awesome for certain use cases. It's great if you want to launch a new version of your environment in parallel. And Elastic Beanstalk gives you a nice little way of swapping between currently running parallel environments, if you will. So you might have an environment that's V1, you might have one that's V2, and only one has an active CNAME. So if you want to go from V1 to V2, Beanstalk gives you an option to click a button and swap that CNAME from V1 to V2. Now this does come with some potential challenges. It can be slightly slower to deploy because you do have to wait for a whole new environment to spin up. But of course, you're not swapping over until that environment is spun up, so it's not a real deal breaker. One thing that can be very problematic, though, is if your clients are mobile clients, many times they do not respect DNS TTLs and will cache DNS records for much longer than is recommended by your TTL. So you might have your CNAME cached by certain clients, and they might be sending requests to your old environment, which will, of course, get black-holed because your CNAME or your application has been updated since. So, however, there are some pros here as well because it's easy to roll back because you haven't terminated your previous environment, and you can just swap that CNAME back over if you have to. So to visualize a blue-green, we might have V1 running in one environment. What we'll do is we'll spin up a new environment here on the side with V2 running. We'll check all the instances into the load balancer. Finally, we'll remove the V1, the old environment, from the load balancer. So this is the CNAME swap. And then finally, we just are left with V2 running in production here. So let's swap over to the demo, and let's take a look at some of these things in practice.
All right, so now walking into the demo here, what we're going to do is open up the Elastic Beanstalk console. And we'll notice that the Elastic Beanstalk console gives you a getting started guide here. And we're going to go ahead and create a new application. So as mentioned earlier, the application is kind of the top-level construct in Elastic Beanstalk. We don't have one here yet, so we want to deploy our webinar demo application here. So we'll go ahead and do this. We'll skip the description because it's not necessary right now. But now we're prompted with some options to choose what kind of environment we'd like to use in Elastic Beanstalk. So we have the two options that we kind of covered a little bit earlier. So we have the web server environment, which is what we're going to use today, which is what focuses on kind of that standard three-tier web application stack. So the Elastic load balancer, your application behind that, and then optionally a persistent store in the back end. Also bundles together all kind of the auto-scaling and load balancing components into the environment. The other option is the worker environment here, which again is a workload that's driven off of an SQS queue. So maybe some asynchronous work, maybe if you have an image processing software or something like that, where you need to kind of crunch some processing, do that asynchronously, and then have the work returned later. So that's queue-driven work for the worker environment here. So we're going to go ahead with the web server. Again, we have to answer some additional questions. So we'll select some platforms. Here's where you can see all the different pre-configured environments that exist. So we support a number of different languages. So this is where you would choose the stack that supports the language that your application is written in. You also have a number of pre-configured Docker environments, but for this use case, we're just going to go with the generic multi-container Docker environment because the application I want to deploy needs a couple of containers deployed together to run the application. So we'll select multi-container Docker here. We do have the option to go with a single instance environment type if we want to save costs just for development use cases or just for testing. But here we're going to go with the full load balance and auto-scaled use case. So moving forward, you do have the option of uploading the deployment artifact for your application here. So in this case, you could upload the Dockerrun.aws.json file. You could upload a zip file or a RAR file that contains your application. Or the whole source bundle for your application. In this case, so later in the demo I can show the update of an environment. We're going to just deploy the sample application, which is just really like a hello world for Elastic Beanstalk. So we're just going to deploy a very vanilla environment here. And we'll update it with an actual application in just a little bit. So looking at deployment preferences, there's some important things to take a look at. Here's some of the different deployment options that we discussed earlier. I'm a big fan of the immutable deployment type, so we're going to go ahead and choose that. And again, that's where we launch a whole new instance to deploy new versions of your application to during application updates. And once the new version becomes available, we go ahead and we terminate the old instances running the old version of your application. So we don't have to configure anything else because we're doing immutable. If we were doing the rolling with additional batch, for example, we'd have to configure our batch size, but we don't have to worry about that here with immutable. So we can move forward. Here's where we name our environment, and so we also need to choose a URL, which will be the public URL for our application once it's finished launching. So you do need to check the availability to make sure this is an available CNAME that Elastic Beanstalk can spin up for you. So we'll just call this demo URL not taken, and we'll hope that's true. So yep, cool. We can use that URL. Other options here, we can choose to associate an RDS database with this environment. So again, if you want this RDS database to be tied to the lifecycle of your environment or your application, this is a good choice. Although oftentimes many customers find that the data for their application in their database is more persistent. It lives much longer than the individual lifecycle of an application. So I generally suggest creating an RDS database outside of Beanstalk if you want that data to persist longer than your application lifecycle. So I'm going to actually connect, in this case, our application to an Elasticache backend. So we're not going to worry about this here. We will create it inside of VPC though, because that's just simply best deployment practices in AWS. We'll also choose an instance type. We'll choose the T2 micro right now. That's the new generation small instances. They give you the option option to do some CPU bursting. So that way, if you have kind of a regular workloads at a very small scale, you can still get some pretty good performance during that time that your application needs that burst processing. We'll also select my pre-created Beanstalk webinar EC2 key pair here. Some other options. Elastic Beanstalk creates an SNS topic for you by default when you launch an environment. And so that SNS topic will notify the email address that you put in here of status changes to your environment. So if your application health goes from OK to degraded, you'll get a little buzz in your pocket that lets you know that something happened, and you can do something with that information afterwards. For the health check URL, I'm just going to use /. I don't have anything special that I need to check my application with here. This is a customizable value, so that's important. Here we can choose the rolling update type, and this is different than what we just selected for our deployment type on the previous screen. This update is where we update the actual application stack on the instances. So not your code, but how we update the underlying supporting application stack. So that might be if there's a new version of Java or a new version of Docker and you want to roll that out to your whole environment. You can use some of the same deployment methodologies that you use for your application with the underlying application stack. So we'll go with immutable because, again, I'm a big fan of the immutable type. We, of course, want the cross-zone load balancing because we want that high availability. We want it deployed across availability zones in the region that we're deploying in. We're going to keep connection draining enabled because that kind of ensures that there's a little bit of a lag time between removing a running version of your application, and we kind of wait for connections that might be active. So if your customers are interacting with your application, we kind of wait for those connections to terminate before we actually terminate the application. So that connection draining timeout is set at 20 seconds right now, which is pretty reasonable for my application. So we'll wait 20 seconds before we terminate any active connections and roll out a new version of the application, for example. We're also going to stick with this enhanced health reporting because I like the visibility into my environment. And then finally, we'll choose a root volume, so the EBS volume that will be attached to the instances. I'm going to go with the general purpose SSD volumes, and we'll choose 20 gigabytes because that seems reasonable here. Moving forward, you can use environment tags to identify your environment, and I would recommend doing that, especially as the amount of resources you have in AWS grows. It can often become difficult to identify what's what, so tags are a great way to sort and query for specific resources in AWS. Finally, we'll go with our VPC configuration here. So as mentioned, we'll launch it into my default VPC. We will associate public IP addresses with the instances that are being launched by Elastic Beanstalk here. Here we're going to choose which AZs to launch resources into. So I want my ELB in 2 different availability zones and the EC2 instances in 2 different availability zones. So we are load balanced across AZs here. I'm going to stick with my default security group because I've kind of already configured it in the necessary way for my application. And then yes, we want my ELB to be visible externally so we can hit it from the internet. Finally, permissions here are really important. So this is how you configure the permissions that your application in Elastic Beanstalk will have in regards to what other AWS services it can reach reach out to. So we're creating an instance role here, which is the permissions that are assigned to your application. I'm going to use the power user role here, which is kind of cheating, just giving some broad permissions to my application. In reality, though, you should assign some the least necessary permissions to your application. So I would configure that role specifically for your application, and if your application only needs to talk to S3, for example, only give it permissions to talk to S3. In this case, we're going to we need our application to be able to reach out to EC2 container registry because we're going to pull a container from ECR. So I'm going to use power user just as an easy way for me to get all the necessary permissions to my application. But again, do as I say, not as I do, and please scope your permissions appropriately for your application. Cool, so we've got everything set up here. We've got all the configuration for the environment. Again, we haven't pointed the environment at our application. We're going to configure our application, build a container from it, and then update the application or the environment with our application in just a second. So let's launch this. We'll let our environment spin up. And while this is actually happening, we can view the events, but we're going to move over to taking our application and getting it ready to deploy as a Docker container into Elastic Beanstalk. So over here in GitHub, I have this repository, which is a simple little application that allows you to basically sign up to receive notifications for a new startup, right? So it takes your email address and your name and it inserts it into a persistent data store. In this case, it's going to be a Redis in-memory database running in Elasticache. So we'll take this, I'll come over to my console, and we're going to git clone this into a directory here. And so we can see we have some files available in here. So let's take a look at those in my editor so they're easier to read. So the first thing to notice is I have this application here, and it is a Python Flask application. And here at the top, we specify what our endpoint is for our Redis cluster. So you can use any Redis cluster. Elasticache is easy for me to use. So I'm going to go over here, and we'll get some information from the Elasticache console. So I'm going to grab my node's endpoint, and I'm going to take that and put that into, didn't copy it, put that into the application, and we will save that real quickly. Great. So my application's been updated. Now I need to create a container from this application. So I have a Docker file that's available here that, most importantly, copies my app into the root of the container. So at /app.py is where it will live. We then do some other things like run it behind the gunicorn application server, which is a small application server dedicated to Flask applications. So we need to build this container, and so what we need to do first is we need to go over here into the console. Again, we're in the directory with a Docker file, and we can simply do a docker build-t. We'll call this webinar demo, and we'll build it here. Great, so I have a container built. But we need a place to store that container as well. So let's go over here to EC2 Container Service, which is where we can find EC2 Container Registry. So I need to create a repository to store this container in. So we'll go ahead and create a new repository. We'll call it webinar demo, as we have been doing. Great. And so ECR is really nice in that it gives you a lot of options here for interacting with it. It basically walks you through the full workflow of creating a Docker container, tagging it appropriately, and pushing it up to EC2 Container Registry. So the first thing we have to do is get the login credentials. And you'll need the AWS CLI installed to do this. So real quickly, I will run this command. And this basically gets a temporary credential that's valid for 12 hours and puts it into your Docker config file. So now I can interact with my repository. I've already done this step to build the webinar demo container, so it already exists. So now we need to tag it with the information for this particular repository. So we will do that real quickly. And so we can do a Docker images. And we can see that I have my webinar demo now tagged with the repository information. And this lets Docker know basically where do I push this container when you actually run the push command. So now we can finally take the push command and we can make sure that container ends up in ECR. So that way we can reference it and we can tell Elastic Beanstalk, hey, we built this container and now it lives at this location in Elastic EC2 container registry. So what we actually need is to grab this URL of where the container lives and edit an additional file. So we've built the container, we've pushed it up somewhere, and now we need to take this configuration file, the Dockerrun.aws.json file, which is what Elastic Beanstalk uses to deploy containers to your running environment. So naturally, you have to point Beanstalk at your container locations. So we'll go ahead and paste this location for the image we just built that now lives in ECR into the Dockerrun.aws.json file. We also have a couple of other, actually one other container defined in this configuration file, which is an Nginx container. And this is just a simple reverse proxy that's doing a proxy pass to the Flask application on port 5000. So really straightforward. This is available in a public Docker Hub. So I'm going to save this as well. And now we should be ready to go. So we've done a couple of things, just to recap. I modified my application. I pointed it at an Elasticache cluster, just so I can store those values in Redis somewhere, right? So it's running an Elasticache. We've also built the image. So we've done that from the Docker file, and you do that Docker build command within the same directory that the Docker file lives. Then we pushed it up to ECR. So it now lives in EC2 container registry, and I can reference it in this Dockerrun.aws.json file. And we reference it by literally providing the URL of the image in the Dockerrun file here. So now that we've done all those things, let's head back over to the Beanstalk console. And let's see if we can figure out the status of our environment. So it looks like it's running the sample application. And there we go. So this is actually a pretty helpful sample application. It points you to a number of sample apps in GitHub, points you to a number of documentation pages that are very helpful for understanding how to run Docker in Elastic Beanstalk, and then a couple of video tutorials, which are quite nice as well. So this is great, but we want to get our actual application up to the environment. So let's do an update of our Elastic Beanstalk environment. So what I need to do now is we're already here. Great. So I need to grab this AWS.json file, Dockerrun.aws.json file, and all I need to do is hit deploy. So essentially what happens here, because we've chosen the immutable update policy, Elastic Beanstalk is going to create a new autoscaling group with a new instance in it and deploy this new code to that new instance. After the new instance has the code loaded on it and we've tested it at the health check that we defined earlier, we made sure it's up and responding with HTTP 200s. We can go ahead and swap it into the load balancer and we can terminate the old instance that was running this old sample application. So some things to look at while this is updating. There's some cool things we can do back in our directory here. So we talked about the EB CLI a little bit. And let's talk about how we can get started with that. So the first thing to do after you've installed it, of course, is in your project directory, you need to run EB init. And so EB init asks you a couple of questions, starting with what's the region you want to use by default. Here we're going to choose 3. Especially because we've already deployed an application into US West. So we want to continue to use that. So we'll hit enter here. And then we'll ask you which application you want to use. We could go through the process of creating an entirely new application through the EB CLI. But in this case, we just want to interface with the one we just spun up through the console. So we'll select one, and we'll go with webinar demo here. Great. So the EB CLI is initiated to use this particular application and correlates the files that we have in this particular directory with that application. So one of the cool things I wanted to show you was the ability to test the configuration of your Dockerrun.aws.json file locally before you actually upload it to Elastic Beanstalk and potentially run into some configuration issues. Because if you're anything like me, you'll probably forget a comma or have some problems that are just because you fat-fingered it. So a nice way to test this out is you can do an EB local run. And this will actually it will parse the configuration file that you've built and run the containers locally on your machine using your local Docker daemon. So you do have to have Docker running on your machine that you're trying the local run on. But this is a nice way of parsing that file to make sure that Elastic Beanstalk is not going to throw any errors once you attempt to launch it in the environment. Other interesting things to look at is that we mentioned earlier that Elastic Beanstalk functions really as an overlay for the resources that run in your account. It's a nice management layer on top. So that applies to EC2 Container Service as well. So back to the EC2 Container Service tab. Close this out. And we'll look at clusters real quickly. So we can see that Beanstalk actually spun up a cluster for us. And then on it, there's a couple of running tasks. There's a couple of registered container instances. And you have the ability just to look at these instances directly. You can take a look at the ECS level metrics, which are also surfaced through Elastic Beanstalk. But you can play with all this stuff directly and interface with it directly. And you don't have to use Elastic Beanstalk once it brings up those underlying resources. So that's pretty neat. So let's get a refresh of all of this. Let's see where we're at. So we're still updating the environment. So we've already added the new instance. We're waiting for it to pass health checks, but it looks like it already has the new task running, and it looks like all we're doing is waiting for health checks here. So that should be pretty quick. Cool. So we've been watching the events here for Elastic Beanstalk, watching the update process go. So basically, we're at the point where the deployment has succeeded, the old instance has been terminated, and the new one has been launched in line with that immutable deployment policy. So we can actually probably just click the URL here and see if the new application is running. Great. So the new application is up and running, and basically we can put in some information here, say we're interested in preview access, and we can sign up. And this data is put into the Redis database on the back end. So pretty straightforward, and there's a number of ways you could do this deployment. Hopefully we gave you an idea of how you can get started, but the Elastic Beanstalk console gives you the ability to do all these updates kind of graphically, and you can also do it through the EB CLI kind of as we showed here. And I would encourage you to kind of explore both options and figure out which works best for you. So moving on, let's get into a couple of new updates to Elastic Beanstalk, and then we'll move into the Q&A section of the webinar.
So we recently released the application load balancer, which is a layer 7 load balancer that is available, generally available now, so to speak. So this is really great. We're adding support for that in Elastic Load Balancer, or I'm sorry, in Elastic Beanstalk, in the EB CLI specifically. So it's not available through the console quite yet, but that is coming. We also support a couple of new languages, so ASP.NET Core, and you can deploy multi.NET applications to a Beanstalk environment now. Also support for EC2 Container Registry, as we just showed. We can pull a container from ECR, which is a great place for storing your containers. And then managed updates. So as we mentioned, that's the ability to deploy new software stacks, supporting software stacks to your underlying infrastructure instead of just deploying your application. So if you want to learn more, there's an Elastic Beanstalk forum. So you can log on to the AWS forums, ask questions. The community is very active, and there's many Amazonians that are available there to answer your questions as well. So do take a look at the forums if you have questions. You can also reach out to us on Twitter directly, so at @AWS_EB, and we're there to answer your questions. So speaking of answering questions, we're going to take a second to collaborate with all of the moderators, and we're going to find the most common questions and reach out and make sure we answer everything that you guys want to know today.
I'd like to again extend a special thank you to our presenter Brandon for his time and a great presentation along with that demo, and to Thomas, Mike, and Adaraj for answering your audience's questions. If you have any comments on our previous and upcoming webinars or suggestions on topics you wish AWS will cover in future webinars, please drop us a line at aws-webcast@amazon.com. Again, that's aws-webcast@amazon.com. Your feedback will help us to improve our webinar programming. Thanks to the audience for taking the time to join us today. Enjoy the rest of your day.